Hello, everyone. Alexander Morari here. I'm the founder of ITKeyMedia, and you have tuned to our podcast about Central Eastern European startups that are in pre-seed and pre-Series A stage. Our guest today is Susan Kim Chomicka, the co-founder of a company called Handerek Technologies, based in Warsaw, Poland, which has developed a state-of-the-art technology of waste plastics conversion into fuels. Very interesting topic. I'm sure we'll have an interesting conversation as well. Hello, Susan.
Hi, how are you?
Yeah, great. Are you ready to hustle? Let's move on.
Sure, of course. Always ready.
Always ready. Yes, great. So round number one, big company. Let's start with the company history and then we'll move on to the founding team.
Yeah, so the company history will tell you a little bit about the founding team. So Adam Handerek, who is my co-founder and the CTO of the company, he has been working on this technology, doing research and development of this over the past over 10 years, 12 years of development. Adam, before he started this project, had worked on a biofuel plant here in Poland as a whole project. And when the subsidies surrounding supporting this biofuel type of technology collapsed, he then started to look at and noticed the huge problem of plastic waste. And the growing problem that it was creating for the waste industry and for the environment. And he decided then to start tackling that as a project. So he originally started that kind of garage research and continued to work on it. This is now the 9th generation pilot that we're working on. And he had kind of developed and worked and, pilot, additional research, next pilot, additional research. The last generation, he thought, okay, this is it. He patented it around the world, only to realize that, scaling this is going to be difficult, from an economic standpoint. So it worked, but economically, it didn't make sense on a larger scale. So then he went back to the drawing board and then with the focus of how to take all this knowledge that he had learned to make this into something that was scalable. And that was his next, push. I met him in 2016 when I came back from, my husband had been posted in China. We came back to Poland and I was looking for a new project. I had worked in developing, I had a consulting company bringing investment between Poland and China and on investment, and a lot of my Chinese clients who were interested in technology. So I started getting involved in that circle. I met Adam, was super impressed by him and his dedication and what he had done, and I really was excited by the sector because as somebody who is very passionate about the environment, this was something that really called to my heart. So he was looking for funding to do this next generation pilot, and I actually took him to China. Had some interested parties, and in the end, I advised him not to do it. I advised him not to do it because it was too small at that point, and I felt that the people who were interested, there were some, we had to be careful on the IP side.
And Sarah, what did you mean? What did you mean? You advised him not to do what again? Just to make sure.
We had some interest from investors.
Yes. Okay.
To invest in his company. They were sector investors on the equipment side, but I advised him that maybe this is not the stage to do it at because the valuation of the company was too small, and they would basically invest at a point at a very early stage, which would give them access to all the IP.
Yeah. It's like a technology hunt, right? Yeah. Rather than investment opportunity for them. Okay. And Susan, how are the roles divided between you two? You're the two founders, I understand, right?
Yeah.
Yes. So CTO, please go on.
Yeah,
sorry.
Of course, he also had two other gentlemen who he had worked with in developing to that point.
Yeah,
and they are in our company. I invested in their next level research, and then in 2018, we felt that, okay, it's ready to, go to the next stage. We created Spookozo and created a new company.
Wait. There's an interesting thread as well. So you had there were two more gentlemen. That's an interesting critical point, basically, in every company when the founding team changes drastically, and then you could say what 2 out of 3 left the company. Did they have to
they
go?
didn't leave. Still in the company.
Sorry, say it again. You joined the 3 existing
Yes.
founders. Yes,
yes.
okay.
But the other 2 gentlemen, yes, they were team members. Yes.
Yeah, okay. And so I understand the technical part is covered by Adam Handerek, the founder, the ideologist, let's say. And what about your own role and function in the company, in the company and in external kind of relationships?
Yeah, so I'm responsible for the business side of it. So fundraising, going out to the market in terms of internationally, particularly in Poland itself, it's can be handled pretty well with the team we have. But anything outside of Poland, most of our the founding team they're not English speakers. Adam is not an English speaker. So,
yeah, that's interesting. I kind of intuitively made the conclusion that Adam Handerek doesn't speak English.
No.
Well, yeah. So this I guessed. What about you? Do you speak Polish?
I do speak Polish, but not fluently. But I have to talk with him in Polish.
Yeah. That's what I was wondering. Yes. How's the communication between you two guys? So that's effective. Okay.
Yeah, we speak in Polish. I have to say that my Polish is not perfect by any stretch of the imagination. But Adam is also a German speaker, and he lived in Germany for many, many, many years. So his brain is very flexible in understanding me because he understands the whole foreign language, situation. So that really helps, I find, because I find that there are types of the more flexible the mind is, creative the mind is, it's much easier to communicate with those people. The people who are very, follow the rules type people, they sometimes don't understand me because they don't understand my structure because I think in English, and so that's sometimes an issue.
As they say, you live as many lives as many languages you speak. Just because every language structures the reality in a different way. And you speak what? I wanted to say, you speak Chinese, English,
well, actually, I'm
Canadian, Polish.
Exactly. I'm actually Korean.
I'm sorry. Yes, you mentioned China. That's why. Of course.
So ethnically, I'm Korean. I grew up in Canada all my life. But my husband, who works for the Polish Foreign Ministry, was posted to China. And he was ambassador there. And so I was living with him there for 6 years.
Look, what about the current team as such? How many people in as a whole, and what's the team structure? Do you have any specific departments? And again, technical versus sales marketing, if there's any. A little bit about that, please.
Yeah, so basically we have involved in the team in one way or the other 12, with the exception of myself and my administration person. The rest are technical. We haven't really had to focus on sales so much at this point because A, we don't have a commercial installation to sell, but B, we have a lot of inquiries from outside to us. So we're in that kind of envious position where the pain in the market is so high that everybody's looking for solutions, and the little bit of media we've received has generated, a lot of inquiries. Inquiries does not necessarily translate into sales, but we do have people who are, waiting to see, our installation working. Yeah. And so at that point, we think that, the sales will be coming through the pipeline.
Yeah, I think this is a very good moment now to move to round 2. The product, the solution, and as well as sales and distribution, let's say. We will try to cover that now. What's the challenge, and what are you trying to create?
Right. So obviously the problem we are trying to solve is all the plastic waste that's in the world that's not currently being recycled. So over 350 million tons of plastic are produced annually, last in 2018. And of that, about 260 million tons are not, are waste, go to waste. And of that, less than 18% is being recycled currently. Even in the European Union, with the strictest controls and with regulations governing sorting and requirements for recycling, the countries vary from anywhere from less than 20 to maximum 50 some odd %, right? So the average is the European Union as a whole is about 35% recycled. The rest of it has to go somewhere. In those countries that allow it, it goes to landfills. In the other countries, incineration. And some countries, they just export it, right? Which is becoming less and less popular as governments are also starting to clamp down on things being exported to third world countries, you know, and moving the problem from here to there. Right? Because we're realizing that, okay, it goes there, but it lands in our oceans, and so it doesn't really solve our problems, right? So that's the problem we are solving. The question is why? Why is so little being recycled? You know, and basically one of the reasons is that the nature of the plastic is multi-material, multi-layered, it's dirty, mixed, and so either A, there's no technology to take that apart. Like for example, if you think about a potato chip bag, you know, if you open it up, it's lined in aluminum. It's nice and shiny, right? That's aluminum. It's not plastic. It's a micro, you know, very thin layer, but that, which is great for sealing the oxygen, and that's why it's there because we don't like preservatives. It then prevents that bag from mechanically being recycled because it's not plastic anymore, it's plastic and aluminum. So how do we separate that? We can't by mechanical recycling. So what we do is we chemically recycle it. We break it down into we break down those long chemical chains down into smaller molecules, right? Smaller particles, which then becomes a vapor. We condense it, and some of the solid waste, like the aluminum things, goes out in the solid waste part, and the vapors, then the plastic that becomes vapors and goes back into being liquid hydrocarbons, you know, like this, right? So it's like, and what that then can be used for is it can then be used as a feedstock to remake plastics again and make virgin plastics. It can also be used, obviously, to, you know, in the traditional fuel sense, right, as an additive or a component of transportation fuels or for heating oil or things like that. Our vision as a company is to, you know, really be part of the circular economy, and so we would like as much as possible as that to go into remaking fuels and remaking plastics again. So
interesting, because I thought that your kind of priority would be on being part of the fuel game, so to say.
You know, to be honest, like that's the easiest for us, right?
Okay.
The easiest would be to be heating oil because that requires the least, least technical purity requirements, right?
Yes,
because you're just burning it. Then the next phase would be to go into things like transportation fuels, because now there's much stricter, narrower parameters of specifications.
What do you mean by transportation fuels? It's where the
jet fuel, you know, jet fuel, diesel, gasoline,
ship,
and ships. Yeah, ships are actually easy because ships are heavy.
They are omnivorous. They can eat everything.
Yeah, they can eat everything. So they're actually easy. So ships, heating oil, that's kind of one phase. The other one is things like, because they require, there's injection oil, you know, engines, right?
Susan, here is a little challenge. This is interesting. So, you know, when I was watching like a couple of media articles or coverages about the company, so I understood that the actual product is half baked, let's say, fuel, and then you add additives to your liquids to make a usable fuel. And you just said right now that, and that was interesting. That's kind of a new and not very obvious in the materials that I've reviewed. You mentioned that your product, the liquid that you showed, is actually an additive to the main base, right, of another like liquid itself. Is that so?
It's not an additive,
yes.
but what I would say, it's a component. So by that I mean, for diesel, it meets the parameters and it is diesel, right?
Yes, to use it in a truck or in a ship, how much in percentage, let's say, volume percentage, how much of your liquid is like pret-a-porter diesel fuel? How much it needs to be enriched or, you know, with these additives and so on? Is it 50% of the end product that could be used by ships and trucks? Is it 80%, 90%? What's
for ships? You could use 100%. For trucks and so forth, technically, like from the specification standpoint, what we see is that it meets all the parameters. So it could technically be used 100%.
Wow.
But well, you would have to add, there are some additives in terms of like, you know, anti-freezing, you know, there's
but that's
like
that's single digits, right?
Yeah, they're small,
yes.
Right? So, but it can basically be used as diesel. The gasoline fractions are, gasoline is not like single malt. It's a blend.
Yes.
Right?
Okay.
It's a blended product. So it's not that straightforward. You cannot just add this 100%. This would be a component.
Yes.
And every blend is different. So it depends on the distiller. It depends on the refiner. Right?
Yeah. Okay.
But what's important in this is that we will never be a fuel substitute in the sense that there's only 4% of the world's oil production goes into making plastic. So even if you took all the plastic in the world and turned it into fuel, it's only 4%, right? We're talking, it's small numbers. But what is important is that if it were to be used as a fuel component, in the European Union, under the Renewable Energy Directive, which is the regulations for decarbonizing transportation fuels, one of the categories to meet decarbonization, you have to, all fuel companies have to have at least 14% to make up that, that has to be part of this biofuels, right? And one of those categories that can be used is what's called
recycled, you could say, right?
Like carbon fuel, right? Renewed carbon fuel, which we qualify as.
Yes,
right?
okay.
So we can be used to meet part of those requirements.
But still, you say that the main focus would be not on entering this circular economy of fuels, I understand, which is interesting, and it's easier, probably much like more visible in the media, and maybe easier to sell probably, and so on. And but then to be part of the circular economy of plastics would be much more promising, right, for you?
Yeah, no. Economically and ease-wise, the fuels would be the best.
Yes.
Right.
Okay.
And one of our competitive advantages is the fact that the quality of our fuel is substantially higher than anything that's on the market right now, compared to competitors in the same type of field as us. And we know that we always suspected this, but it's hard to get, that kind of data, except that we last year entered negotiations with a major petrochemical company from Asia. And they said that they had tested, they've been on the market to find such a technology, and they've been going to a bunch of companies. And our fuel has been by far the best quality fuel of anybody that they've tested. So that,
you mean energetically, right? Wise, energetically and like efficiency wise.
Impurities.
Purity.
Yeah, and quality of fuel. Yeah. So in terms of the impurities, in terms of, the amount of what's called hydrogenation and so forth. So it's the best quality fuel. And there's, different parameters that go into that. We more than fill all the impurities and the parameters and specifications for transportation fuels, but to make plastics, it's even higher. So that's why they were trying to find something as close as possible in order to go straight into their steam crackers. In the plastic side, it's a little bit different than, again, and when you're making plastics, there's a formula, and what they have to do is they take that crude oil, the refineries make a certain blend for them, and they turn around, take that blend, and then put it into their crackers, which then turn around and make polymers to make plastic. For us, and what they found is that ours is the closest that they found, and they want to work on what post-treatment we need to do in order to take it, and work towards trying to take it straight to their crackers.
Yeah. While we are here on the product side, let's say, what caught my eye was this wording, that you are trying to provide solutions that are, and among other things, you say, are effective conversion of waste so as to maximize energy locked in waste. Loved that. Could you expand a little bit on that, this energy locked in waste?
Yeah, so, all waste are everything in the world is made of chemistry, right? It's all chemical compounds, molecules, and so forth, right? So
everything is made of stars and stardust.
So those chemical compounds are made into some kind of formula that produces that. Waste is no different, right? And so waste is only waste because we haven't found a way to harness what that waste is made of in an economical way to be a useful resource, right? So we've tackled plastics first. And we plan to work on additional waste streams, once we get this commercialized. But so we looked at that waste and said, okay, how do we solve this problem of this plastic? We can always, right now, one of the solutions is to incinerate it, right? And there's what's called plastic or waste to energy plants, right? Incineration plants, spalanias, right? So what they do is they burn this waste. That waste burning heats the system, and they convert that heat into energy, into electricity, for example. The problem is it's not very energy efficient because all of that potential energy that's in the plastic, the conversion, the best ones are getting like 18 to 20 some odd percent, 20%, right? Conversion of the potential the energy locked in that plastic into actual electricity. By using our technology, by making it into liquid fuel, you now increase that, double to at least 50%, right? So now you can release 50% conversion if you converted it back into, if you wanted to convert it to electricity, for example. Our goal and our vision is that there's no waste, only renewable resources. And our mission is to find those technologies or to develop those technologies that can achieve that vision, right? To make it a resource that we can reuse again. I think this whole sector is changing quite a lot. And this is the absolute best time to be in this sector right at this point. Because everybody's understanding that it's not the idea of consume, use, buy, make, consume, and throw out. That's not the end of the story, right? And people are starting to understand that this is a circle, right? There is an impact to everything we do on this planet, and everything that we throw out then has its next impact, right? And so as people are starting to understand that, seeing the environmental impact of that, regulations are changing, consumer demand is changing. 81% of people understand that plastic is a problem. And that to me was a huge number, right? 81%, understand that. And 60% of people said that they would pay more to buy something that's more environmentally friendly. That's creating a push to the producers to come up with solutions. And on the other hand, the governments are also being pushed to legislate some solutions as well. So the economic consequences are coming back to the producers, to this whole idea of life cycle costs.
Yes, yes, indeed. And then take into consideration the trend that has been there for several years now, for good several years, of ESG, basically, ESG, let's say, ESG strategies in big companies, especially publicly traded companies. And then this mindset, I can see this, it's in front of my eyes in the last 2 years or so, that this mindset from the kind of a PR gimmick, it cascades into everyday habits of us regular people. Basically, each of us have 3 or 4 containers to segregate the waste. Basically, I myself was very against that in the very beginning. I can admit why, because I saw this as a trick to outsource the segregation, the separation. The separation process to every individual household rather than do this in a centralized location. They save time, money on workforce, labor, and maybe some technology and so on. And they outsource that through these. In the very beginning, I still think this is the case, but let's say it's for the common good anyways, because it creates these conversations with your family, kids, why we do that, why we do that. And so my kids are now fluent in that. I still have problems what waste
where it go.
Yes, where it goes. Yes.
Right. And that's exactly because of those situations that make our solution good. And I have to say that the chemical concept of our technology, it's not new. The chemical concept of our technology is called pyrolysis. It's a form of pyrolysis. And if you look up pyrolysis, there's tons of things out there. Even like people in the garage making with their little kettle can do it. You can just burn it and you can see some oil come out, right? The problem is, how do you do it commercially, right, on a large scale? And how do you do it so that the quality of the fuel is consistent and good? And how do we do this economically? Because there's energy needs to be put in order to break down those molecules, right? So Adam, having his experience from this whole biofuel project, where when you had that Exisa, that subsidy canceled because the government's changed, and then the subsidy gets changed, and we've all seen that, in wind fills or solar projects. As soon as the regulations and the subsidies change, then the industry dies, right? So one of the real objectives for us was to make a solution that didn't require intervention, right? And that's, I think, one of our selling points, is that we produce one of the highest qualities of fuel that's out there, and we do it at a operating cost that makes it very economical and profitable at, even when the oil prices are as low as they are now, right?
So it's profitable and economically viable in a purely commercial environment, right? And subsidy-free, let's say, a subsidy-free viable product rather than subsidy-heavy.
Yeah, and so, of course, right now in the current market where we can be paid to take the plastic to process it, it makes it even more profitable, right? So, for the foreseeable future, there's no way to get rid of this plastic, and so they need to get rid of it somehow. Incineration plants are charging, you can get contracts for things cost 800 zloty per ton, this kind of thing. So 200 euros per ton, 400 zloty per ton, to take the plastic. And so instead of having to pay for the feedstock, you're actually getting paid to take the feedstock, right? And then you're processing, making a product that is a market product, and so you are profitable on that side as well. So it's quite an attractive model right now that also allows us for the future flexibility to build in some more social impact objectives.
Yeah, of course. And just to make sure everybody understands the feedstock, this is actually like raw materials, right? For producing.
So the plastic is the plastic that we have, that we use would be the material. So instead of crude oil to make plastic, or crude oil from the ground, we use the plastic that's being thrown away into making and fuel.
Recycled to be used as raw material. Yeah. That was a new word for me, so I just thought maybe we would help somebody. And let's move on to round 3, competitive landscape, okay?
Sure. So basically, there's a lot of companies now who are, working on the pilot phase, the same phase we are. So it's a really burgeoning market right now because there's so much interest in the market. And because the market is such that the cost of the feedstock and also the interest in the market is such that they're willing to pay a premium for the product. It's making it economical for a lot of these companies to start to work. Some of the companies that I consider our main competitors, one is called Plastic Energy. They're based out of UK, out of Spain actually, Spain, UK. Their installations are in Spain. And why I consider them a competitor is because they actually have working installations and they've been running for a while now. Another one out of the States is called Agrolix. Agrolix is focusing a little bit more on the styrene, which is one of the types of plastic, but they also have proven installations that are up and running. What I see is the cost of the installation. I believe our capex will be lower, significantly lower, and our OPEX is very low as well.
Yeah. So, right now, how many installations do you have like live up and running?
We don't have any major.
It's still R&D, so you have just, I understand, one prototype, right? So this is the.
We have a batch process pilot, and we have what's called a continuous process semi-industrial installation, which is processing will process 50 kilograms per hour, about 300 tons per year. And that's really, again, to test, will it continuously go, and what is the quality of fuel based on all the different types of plastic we throw in there, right? So that's where we are. And we're doing now site permitting process right now for commercial installation. We already have 2 sites which we are currently in the permission process for. And we're doing the engineering and so forth. So hopefully we'll be starting that project later this year, beginning next year.
Yes, and this will be in Poland as well, right? This first.
We have an investor who is looking to build 5 to 7 installations in Poland. Okay,
and that's industry investor or?
It's not an industry investor. It's not a VC. It's actually an angel who is an industrial. Is a manufacturer / distributor, and he wanted to diversify his business. He really loved what we were doing. He produces a lot of plastic waste, and so he knows what the problem is. He knows how expensive it is to get rid of that stuff. He understands the issues around it, and it spoke to him, to do something for the environment. So.
Yes. Okay. Great. Susan, let's move on to round 4. What would be the biggest success and biggest failure and what you learned from it?
So definitely the challenge has been partly money, partly the development time that it takes, right? It's a CapEx heavy project. And so, most, pre-seed seed kind of companies, they're IoT companies, a couple 100,000 and, they're up and running, right? For us, that's a drop in the bucket. And actually it's pretty amazing. I'm like really amazed and proud of ourselves how much we've done for as much money as we have raised, right? I look at this, like we have one investor, you might know them, they also invested in Airly, the bit booster, right? And Wojtek, and when he came to see our institute, he's like, you guys did this for that money? Holy crap, it's pretty impressive actually. But that's because we really we're in there screwing, putting the screws ourselves along with all our contractors, and we've had to really stretch our pennies, and we've done it in a smart way. Sometimes that was a mistake, and so that's one thing I would say was a mistake. Sometimes in the effort to save money, it ended up costing money and time, right? Because, for example, we will pick a contractor because they're available right now and they cost less. And then in the end, we spend so much time fixing those problems because of quality issues, because they didn't do it right, and they made promises they couldn't uphold. But, things like that. So that's definitely things we've learned is to even though it looks like it'll be shorter and cheaper, it often ends up not shorter and not cheaper.
Survive or living through the challenges successful until now was your biggest success, you could say.
Yeah, I would say so.
To make a circular argument, so to say.
Yeah.
Yes.
Yeah, because we've raised, I know that you'll probably be asking about fundraising.
Yes, next round, yeah.
Yeah, so maybe a good segue into that, because we've raised 2 rounds, and also we're unique because I invested a lot. I was also an angel, right? So I was an angel that became, the CEO of the company. So, between the two phases, I've put in almost 2.5 mil PLN. So, and then we raised around $1 million through the Bridge Alpha, and then we raised another we just recently closed in March another round for about €1 million.
That will be a first time ever in our podcast. I will announce round 5 while we are in the middle of round 5. Okay, so round 5, Formula F3 or funding for the future. So we've covered already the history of the investment into the company by now. And tell me, what are the plans for the next 6 months or so? Are you in the market now? Are you in the fundraising mode?
Yes.
And a little bit about your strategy, your focus, the amounts you're looking for. And I'm always asking this as well, the range of dilution you're ready to take. As much as you can share this with us.
That's as much as we're good negotiators. We are currently commissioning our industrial installation, and we are putting together, like I said, our commercial. We're commissioning our semi-industrial pilot, right? And in the testing phase there. So now we've finished the testing. We are now putting together the commercial installation funding. We've actually applied for a grant through PARP. And if we get that grant, then we may be raising some for OPEX, because the grant doesn't pay for our operating costs, right? It only pays for the capital costs. And so that project will be a 2-year project. So we will be probably looking to raise that. If we don't get the grant, then we'll be raising for that second half, which the grant was going to pay for. So we'll be raising for 20 mil.
20 million zloty, I understand. So it's more or less now, you could say, what, just below 5 million euros.
Yeah.
Yeah. Okay.
Yeah.
So, dear investors watching this, 5 million euros would buy you a ticket into the future solution of the plastic problem that all of us are suffering from. Susan, thanks a lot. That's a very interesting project. We wish you all the best of luck. Thanks for an interesting conversation. We'll be keeping an eye on your successes.
Thank you so much for the opportunity to talk about our innovation, and for all of those people out there who are interested in helping and join us in solving this plastic waste problem. Please contact us.
Susan, thanks. All the best. Good luck. So today we hosted Susan Chomicka, a co-founder of a company called Handerek Technologies. That's a company that is developing a technology of converting plastic waste into usable or reusable materials in both as both fuel and plastic feedstock, which is recycled plastic to be used again for production of new plastic, basically, which is part of circular economy kind of approach. Thanks a lot, Susan. All the best. So if you like this episode of our podcast series, follow, subscribe, share, and see you next time. All the best. Bye-bye.